I completed my PhD from NIT Warangal. There I developed the self-compacting concrete. That means for different grades, I have developed the mixed design procedure for self-compacting concrete. And not only the mixed design, even I have developed the stress strain curves for the self-compacting concrete. Because when you are developing a new concrete, you have to know its behavior also. How we know the behavior? If you know its behavior in compression, if I know its behavior in flexure. So if you want to know the behavior in compression and flexure, we know load distribution, load deformation curves, then stress strain curves, then moment curvature relationships. So that all I have developed in my research. So before going to introduce the self-compacting concrete, I have to introduce this Hajime Okamura. He is the father of the self-compacting concrete. In 1986, he has developed this new technology. Because what happens if I am using a regular concrete? One more thing I want to share. Before coming to this post, I am also a assistant executive engineer in public works department. So I know all of you know better what are the practical problems we are going to face. They will give some provisions as per the booklet or as per the provisions, whatever they have given, but it is very difficult to implement all of them. They will say this slump is required, they will say this is the concrete, and even practically we have seen yesterday what type of aggregate is available in the site. So it is very difficult to maintain the whatever the specifications you have, but you have to take a decision with the available material. You have to try to get the good quality of the concrete. So this is your own decision. Suppose if the aggregate is not that much quality, then whether you have to reduce its content, or you have to do what are the measures you have to take, so that even though if some material is not good, then also you are going to get a good concrete. So that practically, I think all of you are doing the same with your experience. So here what happens when we are working with the concrete in regular, generally, even if it is giving a strength, we are not expecting, we are not going to accept it without workability. Workability is the main criteria for the concrete. Strength through workability. That is the concept of concrete in the for the regular concrete. Suppose if you are going for high strength concrete, the concept is also similar to this. We are going to get the same strength through workability. Suppose if I am saying I am developing a M80 concrete or M60 concrete, I have to get the 80 MPa without compromising anywhere this workability properties. Workability means how easy you are going to work with that concrete. It should flow easily all the spaces. And yesterday we have seen that bridge. It is completely fully packed with the reinforcement, heavily reinforced. So in that cases, it is very difficult to compact the concrete. So because of that, he is developed a concrete in such a way that it is going to compact under its own weight. No need of any external vibration. And another thing, see, when we have seen the site, there you are getting any mechanized techniques. It is very difficult. Even they are bending the 32 mm rod also by manually. So in that places, getting a vibrator is also difficult. So that's why you have to develop a concrete. No need of using any external mechanism. No need of any external vibrators. Here in the mixed design itself, we are going to prepare a mechanism. So here the main concept is it should compact under its own weight. The thing is, suppose if you are taking a certain volume, in that you are putting all these ingredients. In our regular concrete, what happens generally, if you see the ratios, coarse aggregate content is more than the fine aggregate, and similarly, fine aggregate content is more than the cement. Like that, you are preparing, and if there are any voids, you are trying to compact, and you want to avoid that voids by compaction. You are trying to minimize the voids. So here in this method, what we are going to do is, at the time of mixed design only, main concept is if it is densely packed, automatically the voids are going to be eliminated. If it is densely packed, directly you will get the, because if it is high density, automatically you will get the high strength. Strength is directly related with the density. In a given certain volume, if you are able to fill all the voids with the fines, no need of any external vibration. We are vibrating because to avoid these voids. So here in the mixed design itself, we are trying to eliminate the voids. For that content, here in SCC, actually what we are doing is, this is the generally coarse aggregate content is much in our regular concrete, and similarly sand proportion, then cement and water. So in the SCC, what we are going to do is, because if I am increasing the coarse aggregate content, automatically the voids are also increasing. So that's why I am going to limitize the coarse aggregate content. I am going to decrease the volume of the coarse content, but I am not going to reduce. I am not compromising the strength. Whatever the minimum coarse aggregate is required for that grade of concrete, that I am fixing. Then, because here I am trying to fill the voids with the fine powder, so that's why here sand content is more than the coarse aggregate content. Because the concept in the preparation of concrete is, whatever the voids formed by the coarse aggregate, they are filled with the sand, and whatever the voids are there in the sand, that are filled by the powder. So here fine materials, just like fine aggregate and powder. Here I am saying powder, not a cement, because let us say if it is a suppose I want to develop a M30 grade concrete. Generally, with the 350 kgs of cement, I can develop a 30 MPa. So directly, if I am using 350 kgs, it is not economical. Here we are thinking in the direction of economy, and we are thinking in the direction of sustainability also. Because what happens if I am using the more cement, more production of cement, then CO2 content is coming, then environmental problems, all that we are seeing. So in this method, what he is given a alternative is, here powder content is required more, but that it is not with respect to cement. Whatever the minimum cement required for the hydration process. See, whatever the strength we are getting because of this hydration process of the cement. When you are curing, it is going under certain hydration process for a 28 days. Regularly, if you are curing the concrete for a 28 days, then it is going to achieve its target strength. So for the minimum, to achieve the target strength, minimum cement content is required. So whatever the minimum content of cement is required, that we are going to keep here, and the remaining content we are going to add as fly ash or GGBS, any mineral admixture we are going to add. The advantage of adding mineral admixture is, it is not only decreasing the cement content, and it is going to form a CSH gel. So that is, whatever the CO2 is there in the hydration process, in that it is going to react with the carbon. From the carbon dioxide, it is taking the carbon and it is forming a CHS gel. With the formation of CHS gel, what happens is, the durability of the concrete is going to be increased. So the self-compacting concrete is not only a high-strength concrete, it is going to give you a high-performance concrete. What is the difference between high-strength and high-performance? Durability of the structure is going to be increased. In high strength, our concept is strength through workability, but in high performance, strength through durability. Not only the strength, but how long it is going to give its strength. I don't want it for 1 year, it is going to give its performance good. After that, you are going to face the durability problems. It is not like that. So it is going to give you a concrete which is high strength and high performance, because of utilizing these waste materials. Whatever the fly ash, silk, UGGBS, metacoilin, like that, we have different mineral admixtures. And another problem of disposal problem is also there from the fly ash and all these things. We are giving two types of solution. One is we are giving disposal problem. Another one, we are going to give a concrete at low cost with a high performance, that is with a high durability. So here the main concept is, we are going to reduce the water powder ratio, because when I am saying automatically powder content is increasing, water is going to be reduced. But how you are going to achieve by reducing a water content, and you are saying it is a self-compacting, means it should flow under its own weight. For that purpose, we are using some superplast sellers. high range water reducing admixtures. If I am adding a high range water reducing admixture, what happens is even its quantity is less, but it is going to show its effect more in the workability properties and in the strength gain properties. Like that, we are going to add a super plasticizer and viscosity modifying agent, because of this viscosity only there is a chance of segregation, there is a chance of bleeding and all these. So if you are able to avoid this viscosity problems, then it can flow easily. So for that purpose, in the SCC, mainly we are using, the main is we are going to reduce the coarse aggregate content. Another thing is we are going to increase the powder. When I am saying increasing the powder, automatically water powder ratio reduces. So to compromise that, I am going to use the super plasticizers and VMA. So these are the some threats to the future, because nowadays, even if you see, so much skilled labor is required. If you see the earlier site, we are working at a height of 20 feet. At that height, you have to pour the concrete. Definitely, you have to use the new technology. Otherwise, you are not going to get whatever the strength you are.
What about the water cement ratio? Do you compromise on that, seeing the water powder ratio?
That is, here we are not going to say water cement, we are going to say water powder. Cement plus fly ash. For that, we are going to add the water. That water, whatever required for hydration process, that we are going to keep. But the remaining, generally, water is added just, if you see the in the practicality, if you are not getting the workability, simply you are adding 1 mug extra. No rules, no regulations. Simply you will add 1 mug extra. But by adding 1 mug extra, you are going to lose your 1 MPa grade of concrete. So instead of that, we are going to add this high range water reducing admixtures. They are going to react in such a way that even if you are adding 5 liters of water, it is going to compromise with 1 liter of water. 1 liter of the super plaster, it is going to affect like a 5 liter water. So like that, we are going to use the super plasters. We are going to use the new technology to get a high strength and high performance concrete.
So, PCC cement already 5 years is added.
Yes, but in practicality,
what you are telling that the cement, what type of cement, whether it is OPC or PPC?
Yes, I am explaining that. When I am doing the experimentation in the lab, definitely I have to take the OPC and I have to decide what is the optimum dosage of fly ash. But in regular practice, if you see nowadays, everywhere you are getting the PCC only. PPC. In the PPC, if you see the cement bag, they will mention what is the generally accepted percentage is 20%. If you see any bag, PPC bag, they will mention 20 to 25% fly ash is added. That is sufficient. If you are going up to M40 grade of concrete, that is sufficient. In some cases, suppose if I want to prepare a high volume fly ash concrete, if I am crossing this 20 to 25 limit, even IS code says if you are adding 20 to 25, it is okay. But if I want to cross the limit, then the mixed design, you have to try practically, then you can suggest. Now we are going up to 40% replacement of cement also. Even high standard, even if you take international standard stadiums also, they are also preparing by using the fly ash, and they are replaced with 40% of fly ash. One example I will say, in Hyderabad, Gachibowli, they have prepared a international stadium, but in that also they have replaced 40% of fly ash. Cement is replaced with 40%. Accordingly, you have to prepare the mixed design. Then only you have to use it.
And what types of fly ash you are using?
In India, we are generally getting 2 types: Class C and Class F. But locally, almost we are.
In the cement company, they are using the fly ash generated from their company itself.
Yes. Here I am using Class C fly ash. Actually, when I am working in Warangal, it is a waste product from the industry.
Yes.
So some from steel plants or from cement factories you are getting. Actually, when I am using from the Andhra cement.